Hey peeps, it's part 4 of my load save memory buffer tutorial. If you want to get to the beginning of this tutorial series, then there's a link below you can click on, or click on this little card that's appearing in the corner of the screen. In this video we're going to add to what we did in the previous videos. This time we're going to overwrite an existing entry in the file. We're going to do that by loading the buffer with the current set of data in the file. Then we're going to go to the corresponding area of the entry we want to overwrite, and then we're going to replace the data at that section and then save it back out to a file again. For this to work, each data set we write either needs to be the same size, or we need to allocate enough room in the buffer to contain each entry. If we were only writing numbers, the data would be the same number of bytes each time, but because we're writing two strings, those lengths vary and we need to have a fixed record size that allocates enough of the buffer to allow the data to fit. We can then determine the position to read and write by multiplying the entry number by the record size. So let's start by going to Object File and to the Create event. We're then going to create just one more new variable which we will call record size, and we'll make that 64, as that should allocate enough space to fit each record entry. Now we're going to create another little helper script, because in the key press space I'm going to want to copy some of this out, put it somewhere else so that we can use it in multiple places. I'm going to create a little script. I'm going to call it make person, and then starting from here, the top line db entry, I'm going to go down and I'm going to take everything where we're creating data and adding it to the map. I'm going to cut it out. I'm going to come down here and I'm going to put it in this make person script, and I'm going to call this, just put a little thing in here saying make a new person. We're going to change this to var entry, and at the end we're just going to say return entry, or return entry apparently. Return entry, there we go. So now what we're doing, anywhere I want to create a new person, I can just use this make person. So we go up here and we say db entry equals make person. I spelled make person wrong. Don't want to make a person. Who wants to make a person? There we go, make a person. So now in the key press space event we simply say db entry equals make person. Now we're going to add the key press enter event. So we go key press enter, there it is. And inside this we want to use the new make person script. So go db entry equals make person. So you can see straight away I haven't had to type out all of this twice, because I've gone in and just put that in a separate script. Next I'm going to say I'm going to get the, so I want to need to do a little bit of shuffle with the database entry, because I need to get the old database entry, get rid of that and replace it with this new entry. Now we could say ds map destroy database square brackets vertical line for the accessor, entry position, close square brackets, and then go database square bracket vertical accessor, entry position, close square brackets, equals db entry. Now technically that will work, because when you destroy the map here, then the database entry in the list at index entry position will just become junk data, and it will say something like undefined or structure doesn't exist or something like that, and then you replace it here and everything's fine. But quite often you'll find there are situations where you'll want to be replacing something with something else, and if you actually just write one over the top or destroy it before you add it, as we're doing here, it can create problems. So it's generally better to actually use a little local variable and get the reference to it first, then replace it, and then destroy it after you've actually overwritten it. So we'll say var old entry equals database entry position. So grab the old one, then we put in this line to override it with the new one, and then in this line we destroy the old one. Now in this instance we're just kind of creating an extra line of work, and it doesn't really save us anything, but there are instances where it's better to do it this way, where you store the thing you're getting rid of in a buffer variable, like a temporary variable, whilst you override it. Then you can get rid of it to ensure that everything's nice and clean. So I've shown you both ways, and we'll now, having created our new entry and gotten rid of the old entry, we now need to set up our display using the script that we created in the previous video. Set up display, and that will be db entry. So we pass it that data map, and it will now start displaying that. Then we need to call the overwrite entry script, and let's drag that overwrite entry script in here. So we're going to create that as a new script and just say overwrite entry at current position. And into this script, what we're going to do is have a var entry pos. So we need to figure out where we're going to start writing it to, and we're going to pass this. This function two arguments. One will be the position we want to write to, and the other will be the data packet that we want to write. So we'll pass. If we just go back to where we do overwrite file, what we'll do is we'll pass entry position, and we'll pass db entry. So entry position is the variable that we're keeping track of where we are via. So this is the one we modify when we do left and right. So that's the data entry we're displaying on screen. So we're going to pass that, and we're going to pass the new data packet we've just made. So in here, entry pos will be argument 0. However, we need to modify this, because what we want is the actual position we're writing to in the buffer, not the index number, which means we need to multiply it by the record size. And that will give us the correct position within the buffer according to that record. So essentially, if we supply it the entry position of 5, then we want to go 5 records in, so it's 5 times record size. Then we're going to say var db entry equals argument 1. So now we've passed in the actual data that we want to use. So we're now going to say, okay, var file equals open quotes file dot buff, close quotes. So this gives us the same file we've been using previously. And as we do with the other scripts, we need to say if file exists, file, close, open squiggly brackets, close squiggly brackets. So we need to check that it actually exists. If it does, we're going to load it into a buffer. So we're going to say var overwrite buffer equals buffer load file. So we load our data into a buffer. Then we need to set the position of where we're going to write to, which is the position of the entry that we want, which is the entry pos variable. So we use the buffer seek for that. So we go buffer seek overwrite buffer. So in the overwrite buffer, we're going to go to the buffer seek start, and then we need to go to the position entry pos. So that position's where we're reading and writing to is now set by whatever variable we pass as an argument. We're then going to use the write data little helper function we made in the previous video. We're going to supply it the overwrite buffer, and we're going to give it the db entry that we supplied as an argument to this function. That writes our data. Having written our data, we go buffer save overwrite buffer, overwrite buffer comma file, and there we go. And then buffer delete, because we need to get rid of the buffer now we're done with it. Otherwise we will leak memory everywhere and have a very bad day. So that's it. That's how you overwrite the data. We just seek to the start position, or we seek from the start position to the entry position, write one set of data, and then we're done. However, because we're now using record size, we need to modify our other files to cope. So we need to go back to load file. And what we're going to do, we're going to add a counter here, var ind equals 0. So this is just going to count what index we're on. Then we're going to replace buffer tell inside the while loop. We replace buffer tell because we don't want to read where it is anymore. We now need to actually set it via whatever index we're currently on. So we use the index counter and multiply that by the record size. We then need to actually manually position where we're writing to with buffer seek. So we say buffer seek read buffer seek start, and then entry. So that sets our write position to the next record position. Then we just scroll down to here, right after where we, after this if loop, after this little if else will do, and we just increase the index with the incrementer, ++. So each time it goes through this while loop, this index variable here gets incremented to see which loop number it is, and that gets multiplied by the number of record sizes, and that sets the entry position. So on the first loop, ind is 0, we multiply that by 64 to get 0, and 0 is a start, so it writes the entry in that first position. Then it goes back round to the loop again, starts the loop again. End is now 1 because it's been incremented down here. 1 times the record size of 64 is 64, so now entry position is set to 64. And we write our next record at 64. Get to the bottom, end becomes 2, up here, 2 times 64, 1 to 8, entry position is now set to position 1 to 8 in the buffer, and we write again. So now there's going to be some empty space in between because you've allocated extra space in case there's large strings that overflow a bit. but otherwise it's neatly writing each record at a set interval, so that when we load it, when we overwrite it, when we amend it, we know where the data is. Okay, so we need to do the same thing with the save file. So before we actually write the data here, we need to manually position the write head, because at the moment all it's doing is it's looping through and it's writing each record right after the previous record. So we need to change that by repositioning the head with buffer seek. So buffer seek, write buffer seek start, and then this will be we'll use the index of the variable that's counting the index of the for loop is p. We're going to use that and multiply it by record size, and then it will save correctly in the right place. Now we need to change the amend file, and this time here buffer tell, once you've finished writing, when you've amended the data to the end of the file and finished writing it, at the moment it's using buffer tell to get that last position at the end, but we don't want that. What we want is, at this point, we're setting buffer seek to the next entry index and then writing it. So what we need to do is advance that index by another record size amount. So we're going to say plus equals record size, and that will advance it so that it's now 64 bytes further forward for the next record next time it comes to this amend. So now if we run it, save and run, so if we press right to go to the next entry, we say, oh hang on, what's going on there? Apparently someone with no name who's age 0 was born in the month Kate Bell. What's up with that? What happens if we press right again? None of this makes sense. Well, actually it does. What we've got here is something called Savegame Compatibility. The first entry is fine because we're starting from byte 0 and reading the record, but the saved data we're loading, which came from the previous version of obj file, that wrote the next record immediately after the first one. So now, when we go to read the first record, but we allocated space, we're now reading halfway through. So when we press right here and get to entry 1, we're actually reading halfway through the next entry, or the third entry, because we're skipping over loads of the data. This is because of a very, very common development issue called Savegame Compatibility. From time to time you have to update your data, and when you do, you often can't load previous files and have to start all over again. This is because you've changed the structure and the format in which they're saved, so that what worked on one version is no longer going to work on this version. This is an issue I had, like, as a tester. I saw all the damn time, especially back in my Total War days, when the campaign map would change every other day. You'd spend all week on a campaign, but after 2 or 3 days, some program come over and be like, "Oh, actually, we've changed the file format again. We've added some stuff and we've changed the saves, and the save games are no longer compatible." Which made it very hard to actually get anywhere in a campaign and test anything. But this is what happens in game development. So what we're going to do here is I'm going to make a little change. Now, if in the next video we're going to I'm going to show you how to do header data, and you can write the version number of the file into the header, and that way when you load it you can check if it's an old version of the file, and you can put in some code to just sort of say, oh, actually let's load it using the old file format, and then correct the data once it's loaded. But we haven't done headers yet, so what we're going to do now is change the file name and just use the space to create some new data. But because sometimes you may find you often need to you may often in development need to chop and change the file name quite often, and I'm going to show you a nice simple way of making it nice and painless to do. See, if you come into the create event and create file num equals open quotes 1 close quotes. And then we go over here. Now, you don't want to go looking for every place that you set the file name to go in and be like file 1. You can use the find and replace, but what I like to do is just insert a file num variable that I can change that's in one place. Like this. Now what I'm going to do is just, if you go to load, just grab the that top line, go Control Shift F, you get your find and replace up, go back to the save, get the second line, paste that in, go replace all. Now you could do that anytime you want to change the file name, but I prefer to just be able to go in here and be like, let's make that a 2, and now it's a completely different file. So now if we save and run, so now if I press space a few times, we've got a bunch of data in there, and if I pick one, say let's say entry 4, Sarah Smith, 56-year-old, born in January. If I press enter, it's now Sean Smith, 33-year-old, born in February. And if I hit the restart game, ding, we're back at entry 0, and you'll see entry 4 is still Sean Smith. So now if you press space, you're amending files to the end of your database, and if you press enter, let's get rid of Tracy Bell, we now have Jane Ramsey. So now you're overwriting data inside the file. Okie dokie. Well, the next video should have a little box appearing in the top right of the screen now. If you click on that, it will take you to the tutorial for showing you how to create the header file, or the header data in the file, which is really useful for putting bits of extra information before you have them to tell your software about the file before it starts loading the actual data contents of the file. So yeah, clicky clicky on the box, and I'll see you in a second.